Here's the essence of building the confidence interval and doing the write-up. Don't get too lost in the thoughts, but here is the first part. Hey, what are we estimating? How are we doing it? We're doing it with a certain confidence interval, a t interval. And then the conditions, well, that's just, can we trust our sampling distribution, all the probabilities associated with it? Then we show our work, and then finally, share the findings in an understandable and concise manner, referring to the parameter, again, that we were estimating. We're going to use the data we collected 2 weeks ago to do a 90% t-interval on the mean resting heart rate of the population. That's the population, seniors who take a class in this hallway. Hey, it's not enough to just say we're doing it on the resting heart rate of these seniors. It's got to be the mean resting heart rate. It is a parameter that we're estimating. Now then, what are the conditions that have to hold true for us to trust our sampling distribution, our theoretical one? Well, we have to establish randomness, the sample size is big, and normality. So we're told we took a random sample, even though it wasn't really all that random, but we're pretending. And the senior population is much larger than 240, our sample size was 24. But now here's our dilemma. How do we establish normality of the theoretical sampling distribution? We either have to have a sample of at least 30 or be told that the population is normal to begin with. Neither is true. Our sample size was 24, and we're not told that the population is normal, so how are we going to establish that that sampling distribution is normal and then be able to proceed, get a confidence interval? Well, here's the deal. We now are going to do a stem plot or a dot plot or whatever and look at the data, and all we're looking for is it conceivable that the data could be from a population that's normal? And in this case, we'd have to say, yeah, there's no problem believing that because it's fairly bell-shaped. That's all you got to say. There's no reason to doubt that the population is normal. That stem plot is bell-shaped. We just established evidence for the population being normal, therefore we're establishing the normality of the sampling distribution. All right, then we go to the work. Well, we need the t-score for the t-distribution that has 23 degrees of freedom and traps 5%. Well, here we go. We go to our t-table and we can find that it's 1.714. Then we come back here and just follow the formula on the formula sheet, the sample mean plus or minus critical score times all that good stuff, and we get that interval right there. And then we summarize. We're 90% confident that the mean resting heart rate of all seniors taking a class in the West 300s is between 68.5 and 74.2 beats per minute. Bam, there we go. One last thing, we may get to problems where the sample size is only 5, and we're going to have to do a dot plot and say, is there any reason to doubt normality? Not really. That little sample of 5 scores could easily come from a normal distribution, so because there's no reason to doubt normality, we're okay to assume the sampling distribution means is normal